This is 4.6 continued, part B. Should finish it up with part B. So here's the summary of the variation of parameter method. So to determine a particular solution of this form, so notice they're still going to have our special cases set equal to f, depending on how to find v1 and v2. But you still have, it's still linear with, so this is linear, of course, and constant coefficients. So that's the key to being able to do this. All right, so first, find y1, y2, linearly independent solutions to the homogeneous case. So that'll be just like we've been doing in the past for solving those systems. Then the particular case, we assume it's going to be of this form. And then we determine v1 and v2 by solving for v1 prime and v2 prime in that system. So we solve in this system here. And then integrate. So going back to this formula. So in practice, solve the system for v1 and v2 and do not use the formula. So don't use this formula. It's pretty much, it's too far ahead. You want to, it's easier to set it up, solve the system, and it'll make more sense that way. So let's look at some examples. So the 1 through 8, we're doing, we're going to do 2 and 4. I think that's all I assigned anyway. Okay, so find the general solution. By variation of parameters. All right, so this is number 2. Solve y double prime plus y equal to secant t. Okay, so first find y1 and y2 linearly independent solutions for y double prime plus y equal to 0. So for the homogeneous case, of course. Now, from 4.3, we know that the solutions are y1 is equal to cosine t and y2 is equal to sine t, and of course linearly independent. So that's because that's the harmonic equation that we can solve for that. So we know the homogeneous case, yh of t is c1 cosine t plus c2 sine t. Okay, so for a particular solution, we form the particular, so for particular, try that again. So for a particular, we form y particular of t equal to v1 of t y1 of t plus v2 of t y2 of t. So we have our y1 and y2. So we need the primes. So y1 prime is negative sine, and y2 prime is cosine t. And so now we substitute into the system, right? The little triangle one I made. So that system is v1 prime cosine t plus v2 prime sine t equal to 0. Negative v1 prime sine t plus v2 prime cosine t is equal to secant t. So that's the system we're solving. So solve the system. So now we don't want to plug into that equation, right? We don't want to go back to here. Okay, so no. Solve the system. So I'll say, write it out like that. So solve the system using, quote, smart choices. We know that secant t is 1 over cosine t, so we could multiply through by cosine, and we get this. Well, cosine and sine. So if you look at that, we can simplify it a bit by doing this. So we multiply equation 1 by sine t and equation 2 by cosine t. So by doing that, you get v1 prime cosine t sine t plus v2 prime sine squared t equals 0 minus v1 prime cosine t sine t plus v2 prime cosine squared t equal to 1. So you got to check that, right? So multiply this by sine, you get sine here, sine squared, and then cosine squared. So this we can see is going to 0. So now add. Okay, so if you add, that's 0. So I'll write that up. Okay, so you add them up and you get v2 prime cosine squared t plus sine squared t equal to 1. So of course that's Pythagorean identity, which is 1. So that implies v2 prime is equal to 1. And then substitute back. So it's back substitution. 1 into the previous equation back here. So take this 1 and you just put it in here. Solve for v1. And you get v1 prime cosine t plus sine t equal to 0. And then you're solving for v1 prime. So v1 prime is equal to negative sine t over cosine t, which is negative tangent t. So that's your v1 to v2, and then so now you integrate. So v1 is equal to the integral of negative tan t dt. So just look that up. That one's not always obvious. That's ln absolute value of cosine t plus k1. And then v2 similarly is just simple run dt. So that's t plus k2. Now you can let those be 0. So we're going to let k1 and k2 be 0 because it's arbitrary and we don't care what they are for the solution. So the particular solution is this. And because it's really small and I don't feel like writing it out right now, we'll just copy it over. So you write down all of them, right? So copy that. I'll go through it, but okay, so that looks like I need to erase it. And then I'll take care of this stuff too. Simplify that a bit. So let's let K1, K2 all be 0. And then your particular is just the sum of those, and then there we go. Just keep it all on one page, I guess. So your particular is just the sum of those two, and then your general is particular plus homogeneous, so you put those all together. So that's ends up being your solution. So the method, just to recap, you find your homogeneous solution, however methods work in the past, what we've done in chapter 4. And then to find your particular, that's where you set up this system to do your appropriate derivatives and then set the system to solve. Okay, let's look at one more. This is example number 4. So solve y double prime plus 2y prime plus y equal to e to the negative t. So first we find our solution to the homogeneous case. So your auxiliary equation is r squared plus 2r plus 1 equal to 0. And so you get r plus 1 squared equal to 0. So you get a double root this in this case. So r is equal to negative 1, a double root. So the homogeneous case is equal to c1 e to the negative t plus c2 t e to the negative t. And that's just from back and forth point, I think 2 or 3. I forget actually what it is. Because when it's a double root, you have to put the t here, and then there's your negative 1 up here. Okay, then for variation parameters, we have y particular is v1 y1 plus v2 y2. And so y1 is your negative t, y2 is t e to the negative t. So we got to take those derivatives in our formula or derivation. So that's just negative e to the negative 1, negative t. And then for y2, you got to use the chain rule. So if you use the chain rule, through the first time, the second, plus the first time through the second, so you get 1 minus t e to the negative t using I keep saying chain rule, it's product rule, sorry. Okay, so then solve the system. So the system is going to be e to negative t v1 prime plus t e to the negative t v2 prime equal to 0. Negative e to the negative t v1 prime plus 1 minus t e to the negative t v2 prime equal to e to the negative t. All right, so then solve for v1 and v2. All right, so it lets you take it from there. Okay, so finish that, and then I'll just paste over the rest of it for you to have. Okay, so pause it and finish that. All right, so we got down to here. So then if you just add those equations together, works out really nicely. Okay. So this, we'll go through this briefly. So if you see, look here, if you just add those up, that's gone, right? So then you just get so yeah, stuff is going to simplify here. Oh yeah, so if you do, so this is the same. So if you just, so basically just doing t plus 1 minus t is just that, e to the negative t. Divide and you get 1, and then the rest is pretty simple. Okay. You could do, again, you want to use smart decisions to solve the system. They're not all the same. They're nonlinear. To solve for that's nonlinear, right? E is nonlinear for a coefficient. So, but you got to use basically good choices. They all should work out nicely in these cases. And then you integrate. See, so that was just t. So v1 prime is that. Then you substitute to find v1, which is negative t, and so you get just negative t and then 1/2 t squared. Then particular then is the sum of those, which you can actually simplify. And then your general is particular plus homogeneous, and so here's your particular and here's your homogeneous. Okay. Last section is next in 4.7.